In example 2, we're going to graph f at x equals x squared minus 2x minus 8 divided by x plus 2 and x minus 3. So we have a quadratic over a quadratic. Now, as I said before, we need to determine the zeros, which are the values of x that only make the numerator equal to 0. So that will be easier obtained by factoring the expression in the numerator if we can. So I think it's minus 4 and x plus 2. And the denominator was already factored, so we'll leave it as it is. So an interesting thing's happened here. Whereas in the denominator, we thought that we would maybe have two vertical asymptotes at -2 and +3, but -2 is also what we probably think at this point is a 0 of the numerator. It's actually neither. At x equals -2, both the numerator and denominator are equal to 0. This is called indeterminate. On the graph, at x equals -2, there will be a hole. The function also simplifies if we cancel out the x plus 2's. It becomes x minus 4 over x minus 3. And we probably should state restrictions here. Obviously, x cannot equal -2, as we're about to see. And x cannot equal 3 because we'd be dividing by 0. So x cannot equal -2 or 3. So we get vertical asymptote at the value of x that makes only the denominator equal to 0 at x equals 3. And we get an x-intercept at x equals 4. Now what we're going to do is we're going to switch over to Desmos right now. And as you can see, I've already put the graph right here. So I'm just going to select it and as you can see here, your vertical asymptote is at 3. Okay, I could probably put in a line x equals 3 just to highlight this. As you can see, the graph is approaching that purple line. And there is the x-intercept we talked about at 4. And if I go over to x equals -2, watch what happens right there. You get -2 and undefined. Really should be -2 indeterminate. So that is it for that particular example.